Welcome to the continuation of organic chemistry. So far, we have looked at the introduction to organic chemistry. We also looked at alkanes and alkenes. In the previous video, we looked at alcohols. In this video, we're going to take a look at carboxylic acids and esters. In the next video, we're going to conclude the topic with polymers. Let's get started. So, carboxylic acids are also known as alkanoics. Their general molecular formula is CnH2n plus 1 COOH. The COOH is the functional group of this family. They all end with the words ethanoic acids. So here is a quick presentation of some examples of carboxylic acids, their molecular formula, their structural formula, and their condensed formula. We have methanoic acids. The prefix is meth. We expect it to have one carbon atom, which it has here, one carbon atom. And this carbon atom is part of the functional group. So the bonding that is involved in this functional group is this, where we have carbon bonded to OH, then bonded to H, then it has a double bond with O. Okay, and the condensed formula is HCOOH. So you forgive me, I didn't have enough space here. Then we have ethanoic acid, which is expected to have two carbon atoms, and indeed it has two, this and this. And the bonding that is involved in this is this, where we have this one, which is the functional group, which is bonded to a carbon, and carbon is populated with hydrogen. So the same manner follows in all the acids. So now, just like in the other families, we talked about preparation, and we're going to use one example because each family has similar methods of preparing the compounds. So ethanoic acid, how is it prepared? So we prepare ethanoic acid using oxidation of ethanol. There are two ways in which this oxidation can occur, and this oxidation has been discussed when we're talking about alcohols. The first is the one that occurs in the presence of bacteria, and the other one is the one that involves in the presence of an oxidizing agent. So in the presence of bacteria in air, we see ethanoic acid being prepared by the oxidation of ethanol by bacteria in atmosphere, air, like this. So we have alcohol here, which is ethanol, then reacting with oxygen by the acts of bacteria. This is converted to ethanoic acid. So ethanol becomes ethanoic acid plus water. The way I used to view this when I was a student, it can just be a good thing even for you to remember, is ethanol, if you put it in air, it will become a little bit sour. So when it becomes a little bit sour, then it has been oxidized to form ethanoic acid. Okay, so it was easy for me to remember. Maybe you can also adapt that. Then in case we don't have bacteria, ethanoic acid can also be prepared by the oxidation of ethanol using oxidizing agents such as acidified potassium dichromate or potassium permanganate. These oxidizing agents bring in oxygen, which is going to react with ethanol and then change it to the acid. So again, the same equation, nothing new. It's just that here we emphasize on the fact that the oxygen has been provided by the oxidizing agent. So what are some of the physical properties of carboxylic acids? Carboxylic acids have the same physical properties as any other acids, such as their ability to turn blue litmus paper red. They have pH value which is less than 7, just like any acid. They also have a sour taste. Yeah, so they also have a sour taste, just like any acid. What about chemical properties? So even chemical properties, they're just the same as acids. We only have one which is just a bit special for carboxylic acids. So the first is they react with reactive metals to form a salt and hydrogen gas, just like the way acids behave. So this is the reaction where sodium reacts with this carboxylic acids, which is since it has one carbon atom and two carbon atom, it's ethanoic acid. So when sodium reacts with ethanoic acid, it forms sodium ethanoate. So this is a salt, and hydrogen is given out. Okay, this is what we expect from an acid reacting with a metal to form a salt and water. For example, sodium and hydrochloric acid, we expect them to form sodium chloride, which is a salt, and hydrogen is going to be given out. The other one is they react with bases to form a salt and water only, in that famous reaction which we call neutralization. So even carboxylic acids, when they react with bases, they undergo neutralization to form salt and water. Example, we have sodium hydroxide, which is a base reacting with ethanoic acid to form sodium ethanoate, which is a salt, and water. Then the third is they react with carbonates and hydrogen carbonates to form a salt, water, and carbon dioxide. So this is also true for any kind of acid. An acid will react with a carbonate or a hydrogen carbonate to form a salt, water, and carbon dioxide is going to be given out. So we have sodium hydrogen carbonate reacting with ethanoic acid to form sodium ethanoate plus water plus carbon dioxide. Finally, the special one, they react with alcohols to form substances which are called esters, and the process is called esterification. And this marks the end of carboxylic acids, and we're going to go quickly into esters. We start esters, these substances that are formed in the process called esterification when an acid reacts with an alcohol. So we'll start with the process that is used to prepare esters called esterification. The definition is, it is a reaction between a carboxylic acid and an alcohol to form an ester in the presence of sulfuric acid. So the definition has this part, which is presence of sulfuric acid. So what is the importance of sulfuric acid in this process? So the importance I'm going to emphasize later. What you can keep in mind now is that sulfuric acid is a drying agent. So that's where you see the connection between the formation of esters and the need for a drying agent. So ethanoic acid can react with ethanol to form an ester called ethyl, ethanoate, and water. Okay, so we have talked about how the various organic compounds are named, starting from alkanes up to alcohols up to carboxylic acids. What about esters? The only thing we discussed about esters is they end with OATE. But where is this coming from? So this is another important point that we're going to discuss. So now when the acid reacts with alcohol, what happens is the acid is going to lose the OH group, while the alcohol is going to lose the H group. When this happens, the OH and the H are going to combine to form water. The remaining parts are going to combine to form an ester. So this is using the structure formula, this is what's happening. So we have the acid here and we have the alcohol here. So when they react, the acid is going to lose the OH and the alcohol is going to lose the H group. So when this happens, the acid and the alcohol are going to combine. The OH and the H are going also to combine to form water, and of course the remaining parts, like I said, they'll form the ester. So this is how esterification occurs. So the equation is simple. We have the acid reacting with the alcohol to form the ester and water. Now note these symbols here. It shows that this reaction is reversible, which brings a bit of complications, as you are going to see. So this is the apparatus that is used in the process. So here is the mixture of the alcohol and the acid. When these are mixed, what happens is the ester is going to be formed and it will be evaporating. Now alcohol has a low boiling point. Because of that, as you are heating here, it can also evaporate. So as it is evaporating, this reflux condenser it is pumped with cold water here, and the cold water comes out here, meaning that this part is cold. So when the alcohol meets gets in contact with the surface here, it's going to be condensed. It will turn from being a vapor into water, and it will go back. So the point of having this is to make sure that the alcohol that hasn't participated in the reaction is taken back. So the conditions for this process to occur are: first, the temperature should be 180 degrees Celsius. Second, there's need for sulfuric acid, which acts as a catalyst, but in essence, a drying agent. So now the important points. The name of the ester follows this order. So to name an ester, you have to get the alcohol, then the acid. The alcohol that makes up that ester, and the acid that makes up that ester. Okay, so for example, if methanol reacts with propanoic acid, then the ester that's going to be formed is going to be called methyl propanoate. So the alcohol, we're going to get the name of the alcohol and put YL here, methyl. Then propanoic acid, we're going to get the proper here, and it will be propanoate. That's how to name esters. Then the reflux condenser, just an emphasis, it is held vertically to prevent the escape of any unchanged ethanol. Now, esterification is reversible. So what are the complications that comes with reversibility? So remember the backward reaction. Oh, sorry, let me say that again. So when esters are formed, when the acid and alcohol react, the ester is formed and water. So because the reaction is reversible, means that when you combine water and the ester, then it's possible to get back the acid and the alcohol. So this backward reaction, where the ester reacts with water to form the acid and the alcohol, is called hydrolysis. In essence, hydrolysis is basically breaking a compound using water. So that's what happens. An ester is broken down to form the carboxylic acid and the alcohol using water. So the forward reaction is esterification. The backward reaction is hydrolysis. So now, because of the fact that the reaction is reversible, and the fact that water can react with the ester to form the acid and ethanol, when the reaction is proceeding, there is a chance that the products can be reacting to forming back the reactants, meaning that the water and the ester which are forming can react to form the acid and the alcohol which are reacting. So how do we prevent this? That's where sulfuric acids come in. Sulfuric acids, it's a drying agent. So sulfuric acid is going to absorb the water that is formed, leaving only the ester. So the sulfuric acid is going to absorb the water, leaving behind the ester. So when there is just the ester, then the hydrolysis cannot occur, and then our esterification is going to continue, and we're going to get our ester. So here are some special properties of esters, or should I say, here is a special property of esters. Esters have sweet smells. Okay, so there are various uses because of this sweet smell. So the uses include: they are used in perfumes due to sweet fruit smells. They are used in food and drink flavoring and preservation. So those are the common uses of esters. Now, esterification seems to be more like neutralization if the ester is looked upon to be more like a salt. So there are some similarities between esterification and neutralization, and some differences. So let's just compare and contrast. So I'm going to start with maybe the similarities, then we'll move to the differences. So similarities between esterification and neutralization are: both reactions produce water. Both reactions are exothermic. They give out heat when they occur. Then the differences. So first, esterification is reversible, while neutralization is not reversible. Second, esterification produces an ester, while neutralization produces a salt. Third, esterification is slower, while neutralization is faster. So these are the differences between esterification and neutralization. And finally, esterification involves a carboxylic acid, which is an example of an organic acid. If you remember, when we talked about acids and bases, we talked about organic acids and mineral acids. I'm sure we did. And an alcohol. So esterification basically involves a carboxylic acid and an alcohol. Well, neutralization involves any kind of acid, whether it's an organic acid or a mineral acid, and a base. So these are the differences between esterification and neutralization. And this marks the end of this part of organic chemistry as we look forward to polymers. Happy solving.